So 5b, okay, which is the first one, okay? I don't know why that's called 5b. That threw me off, okay? Without drawing a sketch, figure out what the coordinates of each point would be under the reflection. Okay. Reflection. Okay? What's the difference between a reflection and a translation, which is what we learned last week when I covered translation? Do you guys remember translations? Right? We're just moving it, right? We're preserving the same shape and location, but we're just taking that shape and we're like moving it across the graph. Is this clear? Is reflection preserving the same shape? So like if I have a shape like, I don't know, this, right? Is this a reflection, do you think? Picture that as the same shape. I know this one looks a little bigger, but like picture them as the same. Would this be a reflection? Just looking at this. Yes or no? No. Because why? This is the same shape. Do you see that? A reflection, you're flipping it, essentially. Okay? So if I were to draw, I'm not great at drawing, but if I had... What's another shape I can draw? So if I had something like this, this is a reflection. You guys see the difference? It's like flipped, right? Is this flipped across the x-axis or y-axis? X, right. So this is a reflection across x. You guys see how it's flipped, right? So there's a difference. It's reflecting. Yes? Okay. I just wanted to cover that. That's the main difference. So if I look at 5b, it says across the y-axis, right? Across the y-axis. Now you can do it two ways. There's an equation for reflection, which is just xy to negative xy. This is negative xy, sorry. Okay? So if you're flipping it across the y, your x's are going to change to negative. Is this clear? Now you can just use this straight up, right? So if I had the left sides given to me, so 4, 3, negative 2, 4, 4, negative 5, negative 1, negative 2, right? If I had all these, right? What is this called again? My what? The word I said for the original shape, do you guys remember? Pre-image, you guys remember that? Pre-image? This is my pre-image. Okay, so if I use this equation, right, which one changes to negative? On all of these. Which one? X or Y? X, right. Hello, hello. Good morning, good morning. So all these X values are negative. Is this clear? So 4, this becomes a what? Positive 2, right? Because it's negative already. Negative 4, positive 1, right? So this is negative 4, 3. Do I do anything with Y? No, it's just Y. Okay? So then this is 2, 4, negative 4, 5, negative 5, sorry. And then 1, 2. Okay? So let me try to circle it. I'm pretty sure this one's dead though. Oh no, it's not. All the x's are changed. Right? Because it's flipped on the x, right? Now if it was flipped, oh no, it's flipped on y, sorry. If it was flipped on x, what would I be changing to all these? If I was flipping across x, what would I change? How would this equation change, first of all? The negative would be on what? The y, exactly. Okay? Now you can do it this way. I also prefer just doing it graphically. So like 1, 2, 3, 4, 1, 2, 3. 1, 2, 3. So if I had a point right here, if I'm flipping it across the y, right? That's my axis of symmetry. Because I'm flipping it across the y, right? So if you had a graph, right? Let's say I had this. Okay? So like that's my axis of symmetry. The amount of points that is in between here, I have to flip the same amount of points on the other side. Does that make sense? So how many points is it from here to the to the y-axis? Sorry, how many points is that? 4. 1, 2, 3, 4. Right. So the other side, I have to do what? The same. Right. It has to be the same. So if I do 1, 2, 3, 4, what point am I on? This is -4, 3 now, right? But I started with 4, -3. 4, 3. Sorry. You guys see that? So the same units across the y-axis. I count the same units on the other side. And did I get the same answer? I did. Questions? Make sense? Okay. So reflection is the same amount of units from the axis of symmetry. In this case, it's y. So if I did 4 here, that means when I flip it, I got to do 4 on the other side, right? Does that make sense? Questions? We're good? Do you understand reflection now? It has to be the same units, okay? Or just use this equation. If you're flipping across the y-axis, just make x negative. That's it. 2, 4, 4, -1, and y equals -x is the function. Okay, let's see. Okay, let me write the letter. Okay, this is your pre-image, okay? It doesn't have the prime or the apostrophe, if you want to call it that way. Okay, so this is pre-image. Okay. So it wants us to use this equation, right? This is key because that's going to be where your reflection's at, right? So whenever it gives you an equation, use it. Okay? So plug in -1. Give me a second. Yeah, plug in -1 here. What do you get? So -1 is your x value, right? -1. So x, y, I'll just write this real quick. Okay? So if I plug in -1 here, I get what? So this is -1. What would my y be? So what does this become for my y? My new y. Any ideas? This would be what? +1, right? So my new y would have a +1. Okay, and then for k, if I do the same thing, I'll write it here. So if I plug in x for 2, this would be -2, right? And then if I plug in the next one, it would be, what would that be? -4, right? So, okay, -4. Good. Okay. And then all my x values, they would all have, wait, yeah, all my new x values, it would have, let me see. I hope I'm doing this right. Yeah, so these y values would become negative now. Okay, so this would be -2, -4, and +1. Okay? So like, you guys see the x, right? It changes to a negative and it becomes my y. Do you guys see that? So like the x is my new y, but it's negative because it's y equals -x. Yes? Go ahead. Okay, so like the 2, that's my x value, it becomes a negative and it becomes my new y. Yes? -1 becomes positive, +1 for y. Okay? Hello. And then for the y's, it's the same thing. The y becomes a negative, it becomes my new x. Right? -2. 4 becomes a negative, it's my x value, -4. And then -1 becomes +1, that's my x value, right? That's because it's -x. Y equals -x, right? So you change the sign, and it's the opposite. So if it was x, it's y now, right? This is my x, -1. It changes to a positive because it's a negative, and it's my new y. It's positive now. The signs change, and the location changes. Yes? Good? Questions? So use this equation, right? That's key. We're good? We're good? Okay. And now all you need to do is graph this, okay? I forgot to write the prime here. I'll just write it real quick. Notation is important. And then just graph it, right? And you'll well, I can't talk. You'll clearly see a reflection once you graph it. Okay. Do you guys want me to graph it for you, or are you good with that? I think you're good, right? You just graph these points. Okay? Just plot it. Okay, good. Just plot the points. Okay, I'll do 6B. I'll do it on the side here, because I think people are still writing. Okay, so this time it's across the line y equals x. Okay? So that equation that should be in your notes for y equals x is xy, yx. So if you have y equals x reflection, okay, you're using that. And what's essentially happening to that? The xy, yx. What is it just doing? It's just what? What's the difference, guys, for x, y, and yx? Like what, are any signs changing? Like positive, negative? Is there any of that? No. The only thing that changes is location, right? So x is now my y, right? X is now my y, and y is now my x, right? It's just flipped, right? So if it was 2, 4, 2, 4, it would be 4, 2. Pretty simple, right? Okay. So if it gives you all these for your pre-image, 4, 3, -2, 4, 4, -5, -1, 2, -2, sorry. Again, this is my pre-image. Okay? You guys see that? Okay. And then I'm changing it, right? So now for my image, I'm going to get what for point A? 4, 3 becomes 3, 4, right. Thank you. Does the sign change? No negatives, nothing. Okay, just keep it as it is. Okay, 3, 4. That's the new point. Okay, you guys get the point? No? Okay, 3, 4. And what does this become? 4, -2, -5, 4, -2, -1. Okay? Very cool. Oh, let me write B prime, C prime, D prime. Okay. Nice. Okay. RQ. Okay. I didn't list the points, but yeah, I didn't list the points. Okay. Now this one is a little different. It says identify the line of reflection. Got it? So, where is my line of reflection? Like, what am I reflecting it off of? Does anyone have an idea? I covered this earlier on the last problem. It's reflecting what? Off the X, exactly. So, maybe if you have a highlighter or something, like, draw like a line here, right? Because it's clearly being reflected, right? Okay, and in order for it to be a reflection, I told you on a graph what needs to be possible in order for it to be a reflection. It has something to do with this line. You remember what I said? I said the same units from the axis of symmetry on the other side has to match when it's flipped. Yes? If that number isn't the same, is it a reflection? No. Does that make sense? She might trick you, right? There's sometimes math people think they're cool and then they say, like, this looks like a reflection, but it's like off by 1 unit. That can be a question, right? So like this can be 3, it's not, but I'm saying like this can be 3 and this can be 2. You know what I'm saying? That is not a reflection. It has to be the same units across the line. Got it? Now this is, right? Because this is 1, 2, and this is 1, 2, right? For all points. All the points. It has to work for everything, okay? So this is a reflection. And on her answer key, she just picked one of the points. So she picked P. So this is, she labeled it this as 2, 5, and this is 2, negative 5. But you can also show it this way too. I'm sure she'll accept that. Okay? Like graphing it and then just showing the number of units is the same for each point. Okay? Like this is R, it's 2, right? Both flipped and unflipped. This is also 2, right? 1, 2, 1, 2. This one's 5, right? 1, 2, 3, 4, 5. And then from here, 1, 2, 3, 4, 5. Same. You can do it that way too. Okay? Any questions? Cool? Good. I think reflection's easier in a way. Yeah. It's easier to see on a graph. You know what I mean? Because translation you can move anywhere, right? Okay. Cool. Let's see. So for 11 and 12, right? It just gives you shapes and graphs. And you have to label where the axis is. That's where you have to find the axis. Okay? And I told you the axis of symmetry has to be the same units, both top and bottom. Yes? So make sure you're counting them from your axis when you draw it. Does this make sense? Okay? So when you, like, if I had something like, I don't know. Let's see. This isn't going to be as accurate, but it's just an example. Okay, so this is -4, this is 0. If I had something like that, and I told you, because this is like 11 and 12. Okay, I'm just giving you an example. If I had that shape, pretend these are the same, but it's flipped, right? Where would my axis of symmetry be? If I had those two shapes right there. So -4, 0. Where would I draw that axis? On what point? Think about it. I told you axis of symmetry has to be the same number.
4.
Say that again? 4? So it's over here? You said 4, right? No, not 4. Where would it be? First of all, is it a y-axis of symmetry or x? A y, exactly. So where would it be? So -4, 0, right? If I were to draw an axis, it has to be the same amount this side, same amount that side, right? So what's in between 0 and -4? What is that? Like the same for both sides? -2, right. So it'd be right here. Does that make sense? Because 2 units this way, 2 units that way. Yes? For this point right here? And it's the same with this point, right? This is 1, 2, 1, 2, right? They're both 2. Whoa, what is that? And then this point, I don't even know what that point is. But it should be the same, right? That's not going to be 2. Okay? I'm drawing a lot of 2's.